Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of trigonometry, and we are continuing our series of questions on JEE Advanced. So today's question we have taken this up from the year 2015. And if I talk about the question which is given to us here, the question says that we need to find out how many distinct solutions are there. So we need to find the number of solutions we have here for the equation which is given to us as 5 by 4 cos square 2x plus cos raised to 4x plus sin raised to 4x plus cos raised to 6x plus sin raised to 6x is equal to 2. So we need to find the number of distinct solutions of this equation which lie in the interval of 0 to 2 pi. So we need to find all the values of x that satisfy this equation which lie in the interval of 0 to 2 pi. We need to find out how many number of solutions are there. And if I see the options given to me here, it says A is 2, B is 4, C is 8, and D is 16. So we need to figure out which of the following options is correct. So let's first solve this equation which we have. So if I see that equation we have, it has 4 by 6 plus cos raised to 4x plus sin raised to 4x plus cos raised to 6x plus sin raised to 6x is equal to. So first of all, let's solve this equation by taking some terms out. So first, if I try to simplify this one, cos raised to 4x plus sin raised to 4x. If I try to simplify it, I can write that as cos square x the whole square. Sin raised to 4x, I can write as sin square x the whole square. So you get it in terms of a square plus b square. So if I have a square plus b square here, I can write that as, I know a plus b the whole square is a square plus b square plus 2ab. So if I have a square plus b square, I can just write it as a plus b the whole square minus 2. That is the expansion of a square plus b square. So when I have this in the form of a square plus b square, I can write this as a plus b the whole square. So cos square x plus sin square x the whole square minus 2 cos square x and sin square x. So if I'm writing it as like this, I know sin square theta plus cos square theta is equal to 1. So I'm just using the identity that this entire thing is equal to 1. So if I have that, this becomes 1 square minus 2 if I take out common sin x cos x the whole square. So if I write that later, let's write that as basically 1 minus 2 sin square x cos square x. So that is your entire expansion. Now let's try to solve the other expansion also. If I solve or simplify this part, cos raised to 6x plus sin raised to 6x. Again, I can write that as cos square x cube plus sin square x. Now, when I write it in terms of cube, it becomes the formula of a cube plus b cube. And a cube plus b cube is a plus b, a square minus ab plus b square. So we get this expansion turning out cos square x plus sin square x in the first bracket. Second bracket, we have it as cos square x the whole square minus cos square x sin square x plus you have this as sin square x the whole square. If I further solve it, I get the first bracket turning out sin square theta plus cos square theta. that is equal to 1. So your first bracket becomes 1. Second bracket becomes your cos raised to 4x plus sin raised to 4x minus cos square x sin square x. Now, first bracket it is 1, so 1 into anything is that same term. So I have only this term left out. I have cos raised to 4x plus sin raised to 4x. I already know that cos raised to 4x plus sin raised to 4x is equivalent to 1 minus 2 sin square x cos square x. So if I write this also again, 1 minus 2 sin square x cos square x minus cos square x sin square x. So you have that same term repeating again. Here only it is minus 2, here it is minus 1. So it gets added and becomes minus 3. So it becomes 1 minus 3 sin square x cos square x. So you have this entire term now. Let's try to solve this further. So if I write that entire equation which I had, first part was 5 by 4 cos square 2x. For the second part, I had this simplified in the form of 1 minus 2 sin square x cos square x. So if I just add that 1 minus 2 sin square x cos square x. The third part, cos raised to 6x plus sin raised to 6x, I can just write that as 1 minus 3 sin square x cos square x. That is equal to. Now, here if I see 1 plus 1, which is 2, that 2, if it goes on the right, becomes 2 minus 2, and that gets 0. So this basically cancels out with this 2. Now, what we are left with, it's 5 by 4 cos square 2x. Here we have minus 2 and minus 3, that makes it minus 5 sin square x cos square x is equal to 0. Now, let's try to solve this idea. So if I try to solve this, we already know that sine 2x, that is double angle, is 2 sin x cos x. So once we have sin x cos x here, I can write that as sine 2x upon. So when I have to square them, I get this becoming sine square x cos square x is equal to sine square 2x upon 2 square, which is 4. So this sine square x cos square x basically becomes sine square 2x upon 4. So I can write that in my other equation as 5 by 4 cos square 2x minus, get that as 5 by 4 sine square 2x is equal to 0. Now once we get this entire idea, I can take out 5 by 4 common, get cos square 2x minus sine square 2x is equal to 0. So if I get this idea now, let's try to solve this further. What I get here is cos square 2x. Again, if I use the identity, I can, by the identity, I can write it as sine square 2x plus cos square 2x is 1. So cos square 2x becomes 1 minus sine square 2x. So we get this cos square 2x as 1 minus sine square 2x. And 5 by 4, if it goes on the other side, gets multiplied and becomes 0. So you are left with only this term, that is cos square 2x minus sine square 2x is equal to 0. So if I write that cos square 2x also 1 minus sine square 2x minus sine square 2x is equal to 0. You get this 1 minus 2 sine square 2x is equal to 0. If I further solve it, I get this between 1 is equal to sine square 2x. So sine square 2x is equal. Taking square root on both sides, I get this sine 2x is plus or minus 1 by 2. Now, when I have plus or minus 1 by root, if I see the curve for sine, I know it is sine 0 is 0, sine pi by 2 is 1. and sine 45 becomes 1 by, right? So sine 45 becomes 1 by root 2. Then you have this same thing, sine pi becomes 0, and sine 3 pi by 4 becomes minus 1 by root 2. So you get 1 by root 2 and minus 1 by root 2 for odd multiples of pi by 4. So if I write this values of x which I get here, so if I write this 2x is sine inverse of plus or minus 1 by root. Sine inverse of plus or minus 1 by root 2 it occurs at pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Then you have 9 pi by 4, 11 pi by 4, 15 pi by 4, and 17. I'm just writing it till 17 pi by 4 because I have been told that the values of x lie from 0 to 2 pi. So if I'm finding out for 2x here, because here on the left I have 2x, the 2x multiple would go from 0 to 4. So I'm just writing all the values of angles between 0 to 4 pi. So that are my values here. If I divide this x by 2. So if I divide x by 2 on the right hand side, your angles also get divided. So you have x minus 3 pi by 8, 5 pi by 8, 7 pi by 8, 9 pi by 8, 11 pi by 8, 15 pi by 8, and 15 pi. So the last term should be 15 pi by 8. So here if I see I have made a mistake here, it should be 15 pi by 4, not 17 pi. So 15 pi by 4 will be the value which will be lesser than 4 pi. After that, if I write 17 pi by 4, that becomes greater than 4 pi. So I'm not writing that. So you have how many values of x satisfying that? So number of distinct solutions that I get here for this question, that is equal. So eight solutions are be possible for this equation which is given to us. That was 5 by 4 cos square 2x plus cos raised to 4 plus sin raised to 4x and plus cos raised to 6 and sin raised to 6x equal to 2 in the interval of x lying between 0 to 2 pi. So you had 8 distinct solutions for this question. So the correct answer becomes solutions. I hope you have understood how to solve this type of questions which deals with solution of the such lengthy trigonometric equations. So just take some parts and solve them, simplify them, and then put them in the equation. That makes it easier for us to solve and get the values of it. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE Advanced. So I'll stay tuned. Also, do like, share, and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of JEE Advanced. So they can also take the benefit from these questions which we are solving every day. Thank you.